I used to like QR codes. Now I think they're quite lame, but we'll get to that later. No offense, Masahiro Hara. When you created them, I could barely change the blast radius in the vintage QBasic Gorillas game. What you did is actually great, and I believe they'll still be around for a while. If you haven't done so, I recommend you watch Veritasium's excellent introduction to QR codes. It would have saved me tons of time had it been published 5 years ago. In particular, I mostly enjoyed the details on error correction. Before we dig in, let me show you a thing I did with QR codes which I wanted to engrave with an industrial laser cutter. In such cases, and since you need to program the path of the toolhead, it is not sufficient to specify the outline of the modules. This makes vectorial QR codes produced by the standard library useless, requires interpolation on bitmap barcodes, and this is obviously suboptimal. To solve this, I modified the library to change black modules to a set of concentric squares so I could engrave this as is with native resolution on sheets of steel plate. I then left those plates to rust a little, and this made the code become almost invisible. Then I lightly sanded the surface of the steel so it would become bright again, but obviously not deep enough so that the black modules would remain rusty. I then applied a protective coat such as varnish or epoxy resin, et voila! Let's get back to some more technical and hardcore stuff. There is the fact that error correction in QR codes is done using the Reed-Solomon algorithm, and this can become a bug and not a feature. Why is that? The way the error correction is spread along the surface of the entire code makes them quite resistant to a stain, but not to random noise. In addition, this is exactly why scratch CDs can be read with little problems, but very old CDs with no scratches at all cannot be read at all anymore. And this makes me very sad. I have a number of computer games that have become useless, even though I had taken them out of their case only a single time. To make it short, Reed-Solomon is quite resistant to pseudo-random noise like stains and scratches, much less to noise with a higher entropy like microscopic degradation of the media through time. This is expressed beautifully at minute 27 of Veritasium's video, and it is quite funny when you think about it because it is the error correction algorithm that makes noise that in turn ends up breaking that same algorithm. This, together with the way the data is spread on the QR code surface, is the reason why the mask patterns are necessary. Data can be hidden in QR codes. At some point I stumbled on a thesis, and I believe Masahiro mentions it briefly near the end of the Veritasium video, implicitly, that clearly stated that by introducing pseudo-random errors in a QR code, a normal reader would dismiss these as noise, whereas a specialized reader would recognize them for a secret message.
No, the message was scrambled. It was the static.
In fact, while playing with QR codes from the COVID certificate, it turned out by comparing the scanned version with the regenerated version of the encoded data that such a steganographic technique was being used. This principle of steganography is very close to what I had been working on, in a slightly less militarized and I suppose more friendly way because the specialized reader becomes the human and the secret message is hidden from the computer. Now this is definitely the most fun I've had with QR codes until now. I was always frustrated that customized QR codes only had the logo in the center, and I wanted to have a larger picture, not just something tiny in the middle. First, keep in mind that when looked from a distance, a QR code will appear to a human as uniform gray because that is precisely how they were designed. We'll use this feature and make another feature out of it. The idea is then as follows. Take a grayscale image and a QR code as input, and match their pixel versus module size. Then, whenever a pixel in the grayscale image is darker than the average gray value, set the matching probability of the corresponding module to be more black than it should be, and the opposite for lighter than average grayscale pixels in white modules. As it turns out, I am applying a mask over a mask, and it took a lot of tuning to have something acceptable for both the human and the machine, but in the end I got it to work. This was tricky, because slight changes in the input image would have a drastic effect on whether the final data could be decoded or not by the machine. The human, however, does not really notice a difference. For obvious reasons, I decided to use the highest error correction level available with added pseudo-random padding in order to increase the apparent resolution of the grayscale image that had now become a human-readable image with what appeared to be pseudo-random noise, which turns out to be a message a computer can understand. The encoded data. In my case, some URLs. Note that the URLs encoded in the code you are seeing now are obsolete. However, they will decode. But this might depend on your device, some are pickier than others. Pseudo-random padding was necessary because encoding a repetition of characters of small strings creates a visible artifact, and this is not desired in our case. This is a consequence of both the Reed-Solomon algorithm and the way the data is spread along the QR code. For the record, I even tried encoding QR codes inside QR codes in such a way, but that turned out to not work so well. What I did not expect at first is that with a theoretical acceptable error count of 30% of destroyed modules, proceeding the way I did would make the QR code break as early as some 4 or 5% errors, and would rarely tolerate more than 15%, even if restricting the voluntary error to the data and error correction code words. I also found the function patterns are specifically sensitive to errors. This shows us that the brain of an average human can be much more efficient for error correction and data processing than a well-trained computer. How cool is that? Anyway, so before I would actually print my QR code, I had to reprocess the modified code to make sure it could be read and that the content was intact after my modification. The pseudo-random padding then had to be discarded by the final client, in my case the web server, and this was an extra hassle because URLs can be longer than Unix file system paths. My encoded content was too long and I had to work around that as well. Since I had yet another bug that I wasn't able to fix in time, well, I had to cancel the operation at festival. Then there was COVID and the next 2 or 3 editions of the festival were cancelled. Then there was a massive storm with winds of over 200 kilometers per hour a few days before the festival that was cancelled again. And this year I was too busy with other things to have time to redo the work involving parsing the official program of the festival and walking around the city to update the paths I had planned. I'm a little upset because it would have given people in real life feeling of what it is to play in a mod such as the wonderful Nemesis. With all this fun, why do I think QR codes are lame? Well, as it turns out, QR codes have a quite low data density and can't hold that much stuff in regard to their pixel space. Also, there is no mechanism to encode a very large amount of data, which Masahiro highlighted in Veritasum's video. QR codes can only be square, which makes them very inconvenient for cylindrical objects and many other shapes, not only because of the viewing angle, but also the deformation of the resulting projection taken by the camera. One project I am working on should solve these issues, unfortunately losing the ability to encode friendly images. Details are way beyond the scope of this video and I am now unable to further work on it because of various constraints. Help me by becoming a patron and subscribing to my channel. Then I might even make it possible for you to have some of the coolest QR codes in existence, tailored just for you. Thanks for watching. If you liked, please like and remember to subscribe because this will help me finish a number of videos of successful projects that are just waiting to be processed. Cheers!